bricks. Bricks have accompanied humanity on our journey through the ages, forming the foundations of our civilizations and sheltering generations beneath their sturdy embrace. The story of their evolution is a captivating tale that winds its way through the sands of time, from the dawn of human ingenuity to the marvels of modern engineering. Let's embark on a leisurely stroll through the centuries, tracing the humble brick's remarkable odyssey. In the serene chronology that follows, we'll unravel the threads of brick-making's rich tapestry, weaving together the innovations and triumphs that have shaped this enduring craft. From the ancient sun-baked bricks that raised the first human settlements to the cutting-edge techniques that construct today's soaring skyscrapers, each chapter unfolds like a well-crafted narrative, inviting you to marvel at the resilience and versatility of this unassuming yet indispensable building block. So let us begin our leisurely exploration, savoring the stories that have been etched into the very fabric of our built environment, and allowing the tactile warmth of bricks to transport us through the annals of human ingenuity and perseverance. Prehistoric era, around 7000 BC. The dawn of brickmaking can be traced back to the ancient settlements of Mesopotamia and the Indus Valley civilization, where the earliest known examples of sun-dried mud bricks were discovered. These primitive bricks were fashioned by hand from a mixture of mud, clay, and organic materials like straw or animal dung, which acted as natural binders. The process of making these sun-dried bricks was relatively simple, yet labor-intensive. The clay-rich soil was sourced from nearby riverbanks or other suitable locations, and then mixed with water to form a malleable paste. This paste was then shaped into rectangular or square molds, often using wooden frames or baskets as guides. The molded bricks were then carefully removed and left to dry in the sun for several days or weeks, depending on the climate and humidity levels. Once dried, these sun-baked bricks possessed remarkable durability and strength, making them ideal for construction purposes. The addition of organic materials such as straw or dung not only helped bind the clay particles together, but also provided insulation and improved the overall structural integrity of the bricks. The use of sun-dried mud bricks was prevalent across various ancient civilizations, including the Sumerians, Babylonians, and Egyptians. These bricks were used to construct a wide range of structures, from simple dwellings and storage facilities to monumental temples and fortifications. The famous ziggurats of ancient Mesopotamia, such as the towering ziggurat of Ur, were constructed using millions of sun-dried mud bricks. In the Indus Valley civilization, which flourished around the same time as ancient Mesopotamia, sun-dried bricks were extensively used in the construction of cities like Mohenjo-Daro and Harappa. These bricks were often stamped with symbols or markings, potentially indicating quality control or ownership. While sun-dried mud bricks were a significant advancement in early construction techniques, they had limitations. They were susceptible to erosion and damage from water, making them unsuitable for areas with heavy rainfall or humidity. Additionally, their strength and durability were limited compared to fired bricks, which were later developed in ancient civilizations like Egypt. Despite these limitations, the use of sun-dried mud bricks marked a crucial step in human civilization's journey towards more advanced building techniques. These early bricks laid the foundation for the subsequent evolution of brickmaking, paving the way for the development of fired bricks and other innovative construction materials that would shape the architectural marvels of later civilizations. Ancient Egypt, around 3500 BC. The ancient Egyptians are credited with a groundbreaking advancement in brickmaking technology, the development of fired bricks. This innovation marked a significant leap forward in the durability and longevity of construction materials, paving the way for the creation of some of the most enduring and iconic structures in human history. The Egyptians discovered that subjecting sun-dried mud bricks to intense heat in kilns or ovens transformed their properties, making them harder, stronger, and more resistant to the elements. This firing process, which took place at temperatures ranging from 800 to 1,000 degrees Celsius, caused a chemical reaction known as vitrification, which fused the clay particles together, creating a dense, ceramic-like material. The production of fired bricks in ancient Egypt was a laborious and time-consuming process. Clay was sourced from the fertile banks of the Nile River and carefully mixed with straw or other organic materials to improve their binding properties. The mixture was then molded into rectangular shapes and left to dry in the sun for several days or weeks, depending on the climate. Once dried, the sun-baked bricks were stacked in kilns or open-air ovens, where they were subjected to intense heat generated by burning fuel sources such as wood, charcoal, or agricultural waste. The firing process could take several days or even weeks, requiring constant monitoring and fuel replenishment to maintain the desired temperature. The result of this arduous process was a brick that was significantly harder, more durable, and resistant to weathering than its sun-dried counterparts. Fired bricks could withstand the harsh Egyptian climate, and their strength made them suitable for constructing monumental structures that would stand the test of time. The Egyptians utilized fired bricks extensively in the construction of their iconic pyramids, temples, and monuments. The Great Pyramid of Giza, one of the 7 wonders of the ancient world, is believed to have been built using millions of fired bricks, each carefully laid and mortared together to create a structure that has endured for over 4,500 years. Beyond their practical applications, fired bricks also held cultural and symbolic significance in ancient Egyptian society. They were often stamped with hieroglyphs or symbols indicating their provenance or the reign of the pharaoh during which they were produced. Some bricks even bore the cartouches, royal names, of the pharaohs themselves, serving as a testament to the importance placed on these building materials. The development of fired bricks by the ancient Egyptians was a groundbreaking achievement that revolutionized construction methods and paved the way for the creation of some of the most enduring and awe-inspiring structures in human history. This innovation not only influenced subsequent civilizations, but also laid the foundation for the continued evolution of brick-making techniques over the centuries. Ancient Romans around 700 BC. The ancient Romans were renowned for their engineering prowess and architectural achievements, and their contributions to the evolution of brickmaking were nothing short of remarkable. Building upon the foundations laid by earlier civilizations, the Romans revolutionized brick production and construction techniques, leaving an indelible mark on the built environment of their time and influencing subsequent generations. One of the most significant innovations introduced by the Romans was the widespread use of mortar in brick construction. Mortar, a mixture of lime, sand, and water, was used as a binding agent between individual bricks, creating a stronger and more cohesive structure. This technique allowed the Romans to construct taller and more complex buildings, as the mortar helped distribute the weight and stress more evenly across the brickwork. The Romans were also pioneers in the standardization of brick sizes and shapes. They introduced a system of standardized brick dimensions, which facilitated more efficient production and construction processes. These standardized bricks, known as bessels, measured approximately 8 inches by 8 inches by 3 inches, and their consistent size allowed for better bonding and structural integrity. Quality control was another area where the Romans excelled. They implemented a system of stamping bricks with the manufacturer's name or the legion that produced them. This practice not only ensured accountability, but also served as a mark of quality, as bricks from reputable sources were highly sought after for important construction projects. The Romans also experimented with different brick compositions and firing techniques. They introduced the use of brick kilns, which allowed for more consistent and higher temperature firing, resulting in harder and more durable bricks. Additionally, they incorporated various additives, such as volcanic ash or crushed pottery, into the clay mixtures, creating bricks with unique properties and enhanced strength. One of the most impressive examples of Roman brick masonry is the Pantheon in Rome, which features a massive, unreinforced concrete dome constructed with lightweight volcanic brick. The innovative use of brick in this iconic structure demonstrated the Romans' mastery of the material and their ability to push the boundaries of architectural design. Beyond their practical applications, bricks also played a significant role in the aesthetic and decorative elements of Roman architecture. Decorative bricks were often used to create intricate patterns, friezes, and mosaics, adding visual interest and artistic flair to buildings and structures. The Romans' advancements in brick-making techniques and construction methods had a lasting impact on subsequent civilizations. Their innovations were adopted and further refined by Byzantine and medieval builders, and their influence can still be seen in modern brick construction practices today. The Romans' contributions to the evolution of bricks have left an indelible mark on the built environment, a testament to their ingenuity and engineering prowess. Middle Ages, around 500 AD to 1500 AD. The Middle Ages witnessed a continuation of brick-making traditions inherited from the Roman Empire, with the craft flourishing across Europe and parts of the Middle East. Although the techniques and methods remained largely unchanged from ancient times, the use of bricks during this period was widespread and played a crucial role in the construction of some of the most iconic architectural marvels of the era. In the early Middle Ages, the production of bricks was often localized and small-scale, with brickmakers catering to the needs of their immediate communities. However, as the demand for building materials grew, larger-scale brick production facilities emerged, particularly in regions with abundant clay deposits or access to waterways for transportation. One of the most significant developments during this period was the rise of monastic and ecclesiastical architecture, which heavily relied on the use of bricks. The construction of grand cathedrals, abbeys, and monasteries required vast quantities of high-quality bricks, and skilled brickmakers were highly sought after. The techniques used in brick production during the Middle Ages remained largely unchanged from the Roman era. Sun-dried mud bricks were still widely used, particularly in regions with milder climates or for more modest structures. However, fired bricks gained popularity for their durability and resistance to the elements, making them the preferred choice for larger and more prestigious buildings. The firing process itself evolved during this period with the introduction of more advanced kilns and firing techniques. Brick kilns became larger and more efficient, allowing for the production of greater quantities of bricks in a single firing. Additionally, the use of different fuel sources such as coal or charcoal became more prevalent, enabling higher firing temperatures and producing harder, more durable bricks. Brick patterns and decorative elements also became more elaborate during the Middle Ages, reflecting the artistic and architectural styles of the time. Intricate brickwork patterns such as herringbone or Flemish bond were used to add visual interest and structural reinforcement to buildings. Decorative bricks, often glazed or molded with intricate designs, were incorporated into facades, arches, and structural elements, showcasing the craftsmanship and creativity of the brickmakers. One of the most impressive examples of medieval brick architecture is the Leaning Tower of Pisa, constructed in the 12th century. This iconic structure, built entirely of brick, stands as a testament to the durability and versatility of the material, despite its famous tilt. Beyond their practical applications, bricks also played a significant role in the cultural and symbolic aspects of medieval society. Brick construction was often associated with wealth, status, and power, with the most prestigious buildings and structures being constructed using high-quality, expertly crafted bricks. The Middle Ages witnessed a continuation and refinement of brick-making traditions, with the material being employed in the construction of some of the most iconic and enduring architectural masterpieces of the era. While the techniques may have remained relatively unchanged, the artistry and craftsmanship of medieval brickmakers left an indelible mark on the built environment, shaping the architectural landscape and influencing subsequent generations of builders and designers. Industrial Revolution, late 18th and 19th centuries. The Industrial Revolution ushered in an era of unprecedented technological advancements and social transformations, and the brickmaking industry was not left untouched by these sweeping changes. This period witnessed a significant shift from traditional, labor-intensive methods to mechanized and mass-produced brick manufacturing, revolutionizing the construction industry and paving the way for architectural marvels on an unprecedented scale. One of the most significant developments during this time was the introduction of machinery and automated processes in brick production. The traditional method of hand molding bricks was gradually replaced by machines that could extrude clay into molds or wire cut them into precise shapes and sizes. This mechanization not only increased production efficiency, but also ensured greater consistency and uniformity in the size and quality of bricks. The advent of industrial kilns and improved firing techniques further transformed the brickmaking process. Large-scale coal-fired kilns, such as the Hoffman kiln and the Bull's Trench kiln, allowed for continuous firing and greater control over temperature and atmosphere, resulting in harder, more durable bricks. These advanced kilns also reduced fuel consumption and increased overall efficiency, making brick production more cost-effective and environmentally sustainable. The Industrial Revolution also witnessed the development of new types of bricks to meet the growing demands of the construction industry. Fire bricks, designed to withstand extreme temperatures, were introduced for lining furnaces, kilns, and other high-heat applications. Clinker bricks, made from the waste materials of coal combustion, became popular for their durability and resistance to abrasion, making them suitable for paving and heavy-duty construction. The mass production of bricks during this period was facilitated by the expansion of transportation networks, such as railways and canals, which allowed for the efficient distribution of bricks across vast distances. This increased accessibility to high-quality bricks fueled the construction of numerous public works projects, including bridges, tunnels, and infrastructure developments, shaping the urban landscapes of rapidly industrializing cities. The architectural styles of the Industrial Revolution also influenced the use and design of bricks. The rise of Gothic revival and neoclassical styles popularized the use of decorative brickwork with intricate patterns, moldings, and ornamentation adorning the facades of buildings. Brick manufacturing techniques advanced to accommodate these intricate designs, with the introduction of specialized molds and tools for creating customized shapes and textures. One of the most iconic examples of brick construction during the Industrial Revolution is the Crystal Palace, built in London for the Great Exhibition of 1851. This massive structure, featuring a cast-iron frame and extensive use of glass, was made possible by the availability of high-quality, mass-produced bricks that formed the foundation and supporting structures. The Industrial Revolution marked a turning point in the evolution of brick production, transitioning from a traditional, craft-based industry to a mechanized and industrialized one. The advancements in manufacturing processes, firing techniques, and Transportation networks during this period not only increased the efficiency and scale of brick production, but also paved the way for architectural achievements that would have been unimaginable in earlier eras, leaving an indelible mark on the built environment and shaping the cities and landscapes of the modern world. Modern era, 20th and 21st centuries. The modern era has witnessed unprecedented advancements in brick production, driven by technological innovations, new materials, and changing architectural trends. This period has seen the brick-making industry evolve from its traditional roots into a highly mechanized and technologically sophisticated sector, producing a wide range of specialized bricks to meet the diverse demands of modern construction. One of the most significant developments in modern brick production has been the introduction of automation and computer-aided manufacturing processes. Highly advanced machines and robotic systems now handle every aspect of brick production, from raw material preparation to molding, firing, and packaging. These automated systems ensure consistent quality, precision, and efficiency, while also reducing labor costs and minimizing human errors. The modern era has also seen the development of new types of bricks to cater to specific construction requirements. Concrete bricks, made from a mixture of cement, aggregates, and water, have gained popularity for their strength, durability, and versatility. These bricks are often used in load-bearing structures, retaining walls, and other applications requiring high compressive strength. Engineering bricks, designed for specialized applications, have also emerged during this period. These bricks are manufactured with carefully controlled properties such as low water absorption, high thermal resistance, or chemical resistance, making them suitable for applications like furnace linings, chemical plants, or high-temperature environments. Lightweight bricks made from expanded clay or other lightweight aggregates have become increasingly popular in modern construction. These bricks offer excellent insulation properties, reducing energy consumption and contributing to sustainable building practices. Their lightweight nature also makes them easier to handle and transport, reducing construction costs. The modern brickmaking industry has also embraced innovative materials and techniques to enhance the performance and aesthetics of bricks. Additives such as recycled materials, fibers, or polymers are incorporated into the clay mixture to improve strength, durability, or thermal resistance. Additionally, advanced glazing and surface treatments are used to create a wide range of colors, textures, and finishes, allowing architects and designers to achieve unique and visually stunning brick facades. Computer-aided design, CAD, and computer-aided manufacturing, CAM technologies have also revolutionized the brickmaking industry. These digital tools allow for the precise modeling and production of intricate brick shapes, patterns, and designs, enabling architects to push the boundaries of brick construction and create complex and visually striking structures. One of the most notable examples of modern brick construction is the MVRDV Gemini residence in Copenhagen, Denmark. This residential complex features a striking facade composed of over 1.8 million glazed and perforated bricks arranged in intricate patterns and shapes that play with light and shadow. The project showcases the versatility and aesthetic potential of modern brick production techniques. The modern era has witnessed a remarkable transformation in the brickmaking industry, driven by technological advancements, material innovations, and changing architectural trends. From automated production processes to specialized brick types and computer-aided design, the modern brickmaking industry has evolved to meet the demands of contemporary construction, while also pushing the boundaries of what is possible with this age-old building material. As we look to the future, it is clear that the evolution of bricks will continue, adapting to new challenges and embracing emerging technologies to create sustainable, efficient, and visually stunning structures that will shape the built environment for generations to come.